Good morning, students. Today we'll learn about some properties of trigonometric functions from the chapter Inverse Trigonometric Function from class 12th Mathematics. So the chapter is Inverse Trigonometric Functions. Inverse Trigonometric Functions. Okay. So now we will study about some properties. Okay, properties of some properties I have that is are most important. If I say that these are the most important properties of inverse trigonometric functions. Inverse trigonometric functions. Okay, so now these are there. They are very important because they are so important. Why they are important? Because they will be used in the exercise, in the in the questions they will be applied. But not only in the exercise, but we can say if we don't remember that, if we don't know about that, what the properties are, how we can solve the questions? So for this, we must know these properties. So let us see what these properties are and how we can remember them. So we have the first property, that is sine inverse 1 upon x is equal to cosec inverse x, and x is greater than or equal to 1, or we can say x is less than or equal to minus 1. Okay, this is the first one. Now we have the second. Now we have another property, that is cos inverse 1 upon x is equal to sec inverse x, and we have x is greater than or equal to 1, or we have that is x is less than or equal to minus 1. Okay, so these are the two most important properties we have. Now the third property I have, that is tan inverse 1 upon x, it will be cot inverse x. Okay, where x is greater than 0. Okay, now they have that is x is greater than 0. Now we have that is second most important property we have, that is that sine inverse minus x is equal to sine inverse x. Okay, where we can say that x belongs to minus 1 to 1. Okay, so these are the most important property which we are discussing. We'll apply them in the numerical. Okay, so we have this second part, that is tan inverse minus x is equal to minus tan inverse x. Okay, so now what they have, where x belongs to, where we have x belongs to R, where R is real number. Now we have the third property, that is cos inverse minus x, cosec inverse minus x. Okay, we have that is minus cosec inverse x. Okay, we have that is x is greater than or equal to 1. Okay, so these are the most important properties we have, but lot more we have to remember so that we can apply them in the numerical. So let us see what they have given. That is now the third property I have, that is first cos inverse minus x. Okay, so what they have given, that is cos inverse minus x will be pi minus cos inverse x Okay. So now we have pi minus cos inverse x, and where we have x belongs to. Okay. So now the next we have sec inverse minus x is equal to, third we have, that is pi minus sec inverse x, that is x is, we have modulus x is the positive value of x. Now we have third one. So what we have? Third one, that is cot inverse minus x is equal to pi minus cot inverse x. Cot inverse x, we have x belongs to R. Okay, so we have this three kinds of properties we have done. Now we'll try to go for fourth. Now they have, that is sin inverse x plus cos inverse x is equal to pi upon 2. Okay, we have where x belongs to minus 1 to 1. Okay, so lots of things we have to do. Now next we have, that is first part we have. Now that we have the second part, that is tan inverse x plus cot inverse x. Tan inverse is equal to pi upon 2, where x belongs to here. Third part now. Okay, so now we have the third part, that is cosec inverse x plus sec inverse x is equal to pi upon 2, where turns to 1. So we have these properties which will be applied in the numerical. We have, first now we have tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, where xy is less than 1. So we have second part, that is tan inverse x minus tan inverse y is equal to tan inverse x minus y plus xy, where xy is greater than minus 1. Okay, so now I have the sixth one which I have divided them. First is 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square, and we have this. Now for the second, 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. X is greater than or equal to 0. And the third part is 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square minus 1 x 1. Okay, so I have this. So these are the important properties we have. Now we'll apply them in the numericals, so it will be more easier to learn about these properties. So it will become more easier. Okay, so now let us try them in the numericals. These are the most important one, because without them we can't, we can't be able to solve the numericals. Okay, so now let us try them in a very simple way, in a very easy way. Let us try to solve them in the numericals. Okay, so we have now how to solve them. Let us see. Now we have the question in my hand, that is from the exercise. They are saying they need to prove. Okay, so what we have to prove? First question they have, 3 sine inverse x is equal to sine inverse 3x minus 4x cube, where x belongs to minus half to half. Okay, so now let us see how we able to solve these numericals. Now what they have given in this is, that is 3 sine inverse x is equal to sine inverse 3x minus 4x cube. We have to prove. So what we will do? We will try to solve this, that is RHS side. Sine inverse 3x minus 4x cube. So what we can do? We can put sine theta is equal to x. Sine theta is equal to x. So we know that 3 sine theta minus 4 sine cube theta, sine inverse. We know that this is a formula for sine 3x, that is 3 sine x minus 4 sine cube x. So we have this formula. So we will write sine 3 theta here. Now I got here 3 theta, and now what is theta? We can say 3 sine inverse x is equal to RHS. So I have here applied the formula which we have learnt in class 11th, that is sine 3x is equal to 3 sine x minus 4 sine cube x. So I hope it's clear now. We have proved this. Now we have the second question. Let us try to solve the second question I have. Now what I have the second question here, that is here also we need to prove 3 cos inverse x is equal to cos inverse 4x cube minus 3x. Okay, so we can say x belongs to half to 1, its value. Okay, so now here also we know the formula, so we'll solve the RHS first. What is RHS? Cos inverse 4x cube minus 3x. Okay, so now what we can do here? Put cos theta is equal to x. Okay, so we have put the cos theta is equal to x. Now what we will do? Well, see what we can do in a very easy way. That is, if I put cos theta is equal to x, I got here for cos cube theta minus 3 cos theta. So here I can write cos inverse cos 3 theta. Now I have 3 theta is equal to 3 cos inverse x is equal to here we have done LHS. Okay, here we have done the LHS equal to. So here also we have applied the identity of the cos 3x, that is 4 cos cube x minus 3 cos x. So this is the identity of cos 3x which we have applied in this, so it becomes equal. So this is how we can easily prove such kind of questions. Now let us try to solve the third question now. Okay, so now let us try to solve the third question now. We have, and this also we need to prove. So let us see what they have given. We have third question now. Third question is tan inverse 2 upon 11 plus tan inverse 7 upon 24. We need to prove it to tan inverse half. What do you need to do? Let us try to solve first LHS. Now what they have given in LHS, that is tan inverse 2 upon 11 plus tan inverse 7 upon 24. So here we'll apply the identity for tan inverse x plus tan inverse y. So we have the identity here, that is tan inverse x plus tan inverse y, that is tan inverse x plus y, tan inverse x plus y upon 1 minus xy. Okay, so there we have applied the identity, that is tan inverse x plus tan inverse y is equal to tan inverse 1 x plus y upon 1 minus xy. So we have the question in my hand. Now let us see how we can easily verify it. Take the LCM of 24 and 11. Both are different numbers, that is even and odd. So we'll multiply. We got here, so 264. So now we'll write here 264, it will 48 plus here I got 77 upon 1 minus 14 upon 264. Okay, so now what I got here, that is tan inverse, we have, that is tan inverse. Now what we can do here, let us try to find. Upon, if I solve this, I got 250 upon 264. What can we do here? Well, try to put it here, 264 into 264 upon 250. 1, we have 2. So now what we can write? Tan inverse half is equal to RHS, okay, which is asked in the RHS. So that is how we able to solve the numerical. Now let us try to do more questions we have. Now we have the fourth question now. Fourth question they have given. In this also we need to prove 2 tan inverse 1 by 2 plus tan inverse 1 upon 7 is equal to tan inverse 31 upon 17. Okay, so here we need to apply the formula. Now we'll try to solve the fourth question. We need to prove it. How will prove? Let us see. So now what we have to do? First we need to solve this. We need to put the value of 2 tan inverse x. So we have the formula here. We'll try to put it tan 2x upon, we have the formula here 1 minus x square. So 1 minus x square. Okay. So now we have tan inverse 1 upon 7. Here we have taken the LHS. So now let us see how we can do it. Now very simple way. Tan inverse 1 upon 1 minus 1 upon 4 plus tan inverse 1 upon 7. So now what we can do here? Tan inverse 1 upon 4 minus 1, 3 upon 4 we have, plus tan inverse 1 upon 7. Okay, so now what we can do here? Tan inverse we have 4 upon 3 plus tan inverse 1 upon 7. Okay, so we have tan inverse x plus tan inverse y. So now we'll apply the formula for that. we have tan inverse x plus we have tan inverse y, that is tan inverse x plus y. Tan inverse x plus y upon 1 minus xy, 1 minus xy. So now we'll try to solve it. We have tan inverse 21, we have 3, 4, 16 plus upon, we have 1 minus 4 upon 21. So now what we have, tan inverse 19 upon 21 upon 21 minus 4, 17 upon 21. Okay, so what I got here, tan inverse 19 upon 21 into 21 upon 17. So I got tan inverse 19 upon 17. Okay, so what that we have, wait. So what we have here, we have done mistake 1. So after taking the LCM, it will be 28. Okay, so after 28, it will be here 31 here. So finally I got my answer here, that is equal to RHS. Okay, so we have tried to prove 4 questions here. Now let us try to solve the 5th question by using the properties of inverse trigonometric function. Now let us try to solve the 5th question now. Okay, so we have 5th question. Now let us try to solve what is the 5th question says about us. The question is, we need to write the function in a very simplest form. Okay, so now let us try to solve. They are saying minus 1 upon x. Here we have x is not equal to 0. Okay, and they are saying that we need to write this function in simplest form. So how we can put x is equal to what? If I try to put the x is equal to, what do we put? Tan theta. So it will be 1 plus tan square theta minus 1 upon tan theta. Okay, so now let us see what we can take here. Now it will be 1 plus tan square theta will be sec square theta minus 1 upon tan theta. Okay, so I have this tan inverse. Okay, so now what we can do here, in a very simple way, we can write sec is equal to 1 upon cos and tan is equal to sin upon cos. So we have tan inverse 1 upon cos theta minus 1 sin theta upon cos theta. So we have tan inverse 1 minus cos theta upon sin theta. Okay, because if I take down as cos, okay, cos theta and into cos theta upon sin theta. So it will be there like this. Okay, so now I have here tan inverse 1 minus cos theta upon sin theta. Okay, so we have this. Now tan inverse 1 minus cos theta upon sin theta. Now we have this tan inverse. So I can put this here as 2. We have, that is 2 sin square theta upon 2, and I can write this as 2 sin theta by 2 and cos theta by 2. Okay, so what we have here, we can reduce this, and also, so I got tan inverse sin upon cos tan theta upon 2. So it will be theta by 2, and what we have put x is equal to tan theta, so we will have theta is equal to tan inverse x upon 2. What we have used here, that is 1 minus cos theta, so we have used cos 2 theta is equal to 2 cos square theta minus 1, or I can say 1 plus cos 2 theta is equal to 2 cos square theta. If I reduce theta by 2, so it will be, so we will have this formula. For one we have, but we have used another formula, that is 2, we have used that 1 minus 2 sin square theta, that is 2 sin square theta is equal to 1 minus cos 2 theta. And now what we have, if I reduce it by 2, so 1 minus cos theta, I can write 2 sin square theta by 2, and I've written sin theta is equal to, that is, we know the formula, 2 sin 2 theta is equal to 2 sin theta cos theta. Now we can say, if I reduce by 2, I got 2 sin theta by 2 cos theta by 2. So that is how we have used these two formulas in this numerical. Now let us try to solve another question. We have solved today only 5. So let us try to solve the 6th one now. So now we have the 6th question. Now let us see. Let us see how we can solve this. The question I have, that is, they have given the question, that is tan inverse 1 upon x square minus 1 in under root. We have, okay, so we have this, and we have given 1. Okay, so tan inverse 1 upon x square minus 1. What we can do here, we can take as x is equal to, what we can put here, if I try to solve, we know the identity, that 1 plus tan square theta is equal to sec square theta. Okay, so we can put x as tan theta. Now sec theta, it will be cos theta, so we need to make it as tan theta. So now what we can do here, let us see. Okay, so I have this 1 plus tan square theta is equal to sec square theta. So now I will put here x is equal to, we'll try to put as, what will take here, x is equal to sec theta. So now what will happen, if I take sec square theta minus 1, so what will become, it will tan inverse 1 upon tan theta. We know that because sec square theta minus 1, what is sec square theta minus 1 is tan square theta under root, so it will be tan theta. Okay, so now we have 1 upon tan theta, but I can take this tan inverse 1 upon cot theta. So we know that tan inverse cot theta will be cot, we can write tan 90 minus theta will be cot theta. So what will happen, pi by 2 minus theta. So I have pi by 2 minus, what is theta here? Theta will be, what I have taken here, I have taken sec theta, sorry, I have taken that sec theta is equal to x. So it will be sec inverse x. Okay, so that is how we solve the question. Now let us try to solve the seventh question we have. Okay, so we have. Now let us try to solve the seventh question I have. That is, they have given tan inverse. We have 1 minus cos x upon 1 plus cos x. So I have this, and they have given also that x lie between 0 to pi. Okay, so let us see how we can do it. Now we know the formula for cos 2x, that is 2 cos square theta minus 1 and 1 minus 2 sin square theta. So here I will try to put it as 1 minus cos theta. It will be 2 sin square theta by 2 and upon 2 cos square theta upon 2. So what will happen? We have root. So it will be tan inverse tan theta upon 2. Okay, so I will have theta upon 2. So we have this theta upon 2. Oh, sorry, we can take 2 sin square x by 2 here. Okay, so it is x by 2. Okay, so we have this. So now that is how we solve the question here. Now let us try to solve the 8th question. Now I have 8th question. What this says, we have solved, sorry, 8th question. This is the 8th one I have solved. Now we will try to solve the, okay, I have solved this, sorry, 7th question I have solved. No? Now we will try to solve the 8th question I have. 8th question is tan inverse cos x minus sin x upon cos x plus sin x. Okay, we have this where 0 to x to pi we have. Okay, so now cos x minus sin x. So what we can do here, divide by cos x, 1 minus, we have here tan x, okay, upon 1 plus tan x. So what I can put here, tan is tan pi by 4, because we all know 1 is tan, 1 is the value of tan will be 1 at pi by 4. Okay, so what I have used here, tan pi by 4 plus tan x. Okay, so now we know the formula for this tan x minus y. We know the formula for that. So we'll have this tan inverse pi by 4 minus x we have. Okay, so now we have pi by 4 minus x. So that is how we able to solve the numericals. Now let us try to solve the next one, what they have given. 9th question. Now we have just solved only 8. Now we'll try to solve the 9th one. I hope it's clear to everyone. It's a very simple question they have given, and this exercise just we have to apply the properties only. Okay, so now we have the 9th question in my hand, that is tan inverse x upon a square minus x square under root. Okay, so they have given this where you have x less than a. So now what we can do here is, what we can put here, they have given this, we can put as x is equal to a sin theta. So that we have, if I put as a sin theta, we have a square minus a square sin square theta under root. Okay, now what can happen here, we have tan inverse a sin theta. Now I will try to take square a square common, 1 minus sin square theta. Okay, so now I will apply the identity, that is tan inverse a sin theta. A square will take outside, so it will be a, and 1 minus sin square theta, it will be cos square theta, but it is in under root, we will have cos theta. So we have this. So we have tan inverse tan theta. So we have theta. What is theta? If I take theta here, we'll have sin inverse x upon a. Okay, so that's how we solve the question. Now we have to solve this 10th question now. So now what the 10th question says about? The 10th question is tan inverse. We have the 10th question. What the 10th question says? Tan inverse 3a square x minus x cube upon a cube minus 3a x square. So what we can do here, we need to, they have given the conditions also. Okay, so they have given a is greater than 0 and minus a upon root 3 x a upon root 3. Okay, so that is what we have here. Now let us see how we can solve. We can divide in numerator and denominator. Divide in numerator and denominator by a cube. So it will have 3x upon a minus x upon a cube upon, we have 1 minus 3x upon a square. So we know that is the formula of that. That is, the formula is tan 3x minus x cube upon 1 minus 3x square. So we'll have the formula here for tan inverse tan 3 theta. So it will have 3x upon a. So we have this. So like this we can do. Now tan inverse tan 3x upon a. So we have 3x upon a is my answer. Okay, we have the formula for this tan 3 theta, that is 3x minus x cube upon 1 minus 3 into x square. So that is the formula we have. So now that is how we are able to solve the numerical. So what we have in this, if we see that we can put x upon a is equal to tan theta. So we'll have tan inverse 3 tan theta minus tan cube theta upon 1 minus 3. We have tan square theta. Okay, so we have this tan inverse tan 3 theta. So we have 3 theta here. Now 3 into theta will be tan inverse x upon a. So that is how we are able to simplify the trigonometric functions by using the various formula. I have here used one formula, that is tan 3 theta is equal to 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Okay, so that is how we are able to solve the numerical. Now let us try to solve the 11th question. Now we have just solved 10 questions. Now we'll try to solve the 11th one. So now we have the 11th question now. So now we'll try to see how we can solve the 11th question here. So I have the question in my hand. That is, a question is 11th, that is tan inverse 2 cos 2 sin inverse half. I have this. No, I will not use here. We'll use this. Okay. So now we have this. So now let us see how we can easily solve tan inverse 2 cos into. No, it's not into. Now we have 2. I can get half as sin inverse sin pi by 6. Okay. We have this. So what will happen? It will take flower bracket now and here this one. Okay, so we'll have tan inverse 2 cos. It will be 2 into pi by 6. Pi by 3 we have. So now tan inverse cos pi by 3, cos 60. So cos 60 will be, we have the value, that is cos 60. So cos 60 will be half. So we have tan inverse 1. So we'll have pi upon 4. Okay. So this is the question we have solved, in which we need to find the value. Now let us try to solve the another question we have, 12th question now. So 12th question is cot tan inverse A plus cot inverse A. We have the identity here. If I say that is tan inverse x plus cot inverse x is equal to pi by 2. So cot pi by 2. So what will be the value here? We'll put. Now we know the value of cot pi by 2 is equal to 0. So I hope it's clear to everyone. Now we'll try to solve the 13th question we have. So the 13th question I have, that is tan inverse 1 upon 2. We have sin inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. Okay. So I have this, and they have given that x is less than 1 and y is greater than 0, and we have xy is less than 1. So this is, I have the question. So now let us try to solve this. They have given, that is 10 half. So now we'll try to solve this kind of function. To simplify it, what we can do here, put x is equal to tan theta and y is equal to tan phi. Okay. So now what we can do here, let's try to put it half, that is sin inverse 2 tan theta upon 1 plus tan square theta. We have plus cos inverse 1 minus tan square phi upon 1 plus tan square phi. Okay. So we have this. So now what we can do here, tan 1 upon 2 we have. Now we have the formula here, that is sin inverse 2 tan theta 1 plus tan square theta. So I can write it here, sin 2 theta here, plus we have cos inverse. So we'll have this cos 2 theta here. Okay. So we have this. So we have. Now we have this. So what we can take here, phi. So it will be tan half 2 theta plus 2 phi. So we have tan theta plus phi. So now what is tan theta? We can write here. We have given the theta here. So you can put here tan inverse x plus tan inverse 5. So I have this, so we can easily simplify such kind of functions. Now we have, instead of using this, we can usually solve the formula, find the formula for that. Tan x plus y will be tan x plus tan y upon 1 minus tan x tan y. Okay. Now we know that tan theta is x, so we can say x plus y upon 1 minus xy. Okay, so that is how we able to solve. Now we'll try to try to solve the 14th question. Now we have just solved only 13. So let us see how we can do. So now we have the 14th question in my head. So what is the 14th question? They are saying that if sine inverse 1 upon 5 plus cos inverse x is equal to 1, what we can do? Then find the value of x. Then we need to find the value of x. Okay, let us see how we can easily find it. We have sine inverse 1 upon 5 plus cos inverse x. You can put what is, where is in sine 90? Pi upon 2. So what we can do here? In a very simple way, we got sine inverse 1 upon 5 plus cos inverse x is equal to pi upon 2. Okay, so we have this sine inverse 1 upon 5 plus cos inverse x is equal to pi upon 2. So we have the identity, we'll apply here. So now what we can say, that is cos inverse x is equal to pi upon 2 minus sine inverse 1 upon 5. So we'll have a sine inverse x is equal to cos inverse 1 upon 5. So we'll have x is equal to 1 upon 5. As we all know here, that is sine inverse x plus cos inverse x, it will be 1 upon 5. 1 upon cos inverse x is equal to pi upon 2. So that is what we have applied this identity here. Okay, so we have. So now we have, that is 14th question we have. Now we'll see what we can apply here. So we have this 14th question. Now we'll try to see what the 15th question says about. So now we have, the 15th question, that is they are saying if tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 is equal to pi upon 4. So now find the value of x. Okay, now what they are saying, we need to find the value of x. What we can do here, in a very simple way, we'll apply the identity tan inverse x plus tan inverse y. It will be tan inverse x plus y upon tan inverse x plus tan inverse y. We have the identity here, we'll apply here upon 1 minus xy. So it will have x y we have. Okay, so we have this identity. So now we'll try to sort it out. This, if I say this pi upon 4, so we can say now, if I solve this, x minus 1 plus x plus 1 upon we have x minus 2 x plus 2 upon we have minus x square minus 1 upon x minus 2 x square minus 2 square. A minus b into a plus b will be a square minus b square. It will have 10 pi by 4. It will be 1. So we have 2x upon x square minus 4 upon x square minus 4 minus x square plus 1 upon x square minus 4. So it will be reduced here. We have 10 45, that is 1. Now what we can do here, we have this value, that is 2x upon we have minus 3 is equal to 1. So you can take 2x is equal to minus 3. Okay, we have this value, we have 2x is equal to minus 3, or we can say x is equal to minus 3 upon 2. So that is how we try to find the value of x. Now we'll try to see what mistake we have made here. That is what we can do here. Very simple way. If I add this, I got x square minus 4. Okay, so I need to do is x minus 1 into x plus 2 plus x plus 1 into x minus 2. Okay, so now upon I have 1 minus x square minus 1 upon x square minus 4. So we have this is equal to pi upon 4. So we have here x square plus 2x minus x minus 2 plus x square minus 2x plus x minus 2 upon I have x square minus 4 into, or upon I can take x square minus 4 minus x square plus 1. So I have this, so I got this x square minus 4 is equal to pi upon 10 pi by 4. Okay, I will take inverse set it on this side. So now I got this value here. So what I got, let us see. If I reduce this 2x by 2x and x by x, so we have 2x square, okay, minus 4 upon we have, it is also reduced, so we have here minus 3 is equal to 1. So I can take 2x square minus 4 is equal to minus 3. 2x square minus, we can take minus 3 plus 4. We have 2x square is equal to 1. We have x square is equal to 1. So we have x is equal to plus minus half. Okay, so that is what I got my exact value for this question. Now let us try to solve the 16th question. In my hand I have this 16th question, that is what they have given, and this, that is we need to find the value. I hope it's clear to you. So now we'll move on to the next question. So what will be my next question? Let us see. The next question I have, that is sine inverse sine 2 pi upon 3. Okay, so I have this. So sine inverse sine, I can write here sine pi minus pi upon 3. Okay, so now what else I can write here? That pi minus will be sine pi upon 3. So it will be pi upon 3 is my answer. So that is how we able to find the value of such question, that is sine inverse sine 2 pi upon 3. I can write that pi minus pi by 3, that is I am talking about that sine is positive in second quadrant, in first quadrant also. So I put this, so I got sine pi by 3, so I got pi upon 3. So that is how we able to find the value. We have here tan inverse tan 3 pi upon 4. So I can write here tan inverse tan pi plus, or no, we'll take, if I take this value, what will happen? Let us see. We have, so now we have the value here, that is tan inverse. I can write tan as pi minus pi upon 4. So we have now, it will be tan inverse, tan pi minus 4 minus tan pi upon 4. Okay, so we'll have value minus pi upon 4. So that is how we are able to solve the question. Now let us try to solve the 18th numerical I have. That is the 18th question I have. That is tan sine inverse 3 upon 5 plus cot inverse 3 upon 2. Okay, we have this. What we can do here, what we can put here, sine inverse 3 upon 5 is equal to x, so that sine x is equal to 3 upon 5. Now I can use an identity, that is sine square theta plus cos square theta is equal to 1. So now I can say cos square theta is equal to 1 minus sine square theta, and cos theta will be, if I try to find, that is cos x, if I try to find, I got 16 upon 25, that is 4 upon 5. So now I can find sin x upon cos x. We have tan x. So we have here, what is sin x? 3 upon 5, 4 upon 5. So I got 3 upon 5 into 5 upon 4. So I got 3 upon 4. And now what we can do is put this y. So cot inverse 3 upon 2 is equal to y. So I got, what I got here, 3 by 2 is equal to cot y. So tan y will be 2 upon 3. Why I have done this? To evaluate this. How? Let us see. In a very simple way, we will try to see why I have done this. Because we can see that I have taken x plus y. So now tan x plus y will be tan x plus tan y upon 1 minus tan x tan y. So now we can put a value. What is the tan x? 3 upon 4 plus 2 upon 3 upon 1 minus 3 upon 4 into 2 upon 3. I have 2. So I got this here 12. 9 plus 8 upon 1 minus 1 upon 2. Okay, so what I got here, 17 upon 12 upon, it will be half. So 17 upon 12 into 2 upon 1, 6. So I got a value 17 upon 6. Now is the answer for this. So now we'll try to solve the another question we have. Okay, so it is. So now let us try to solve another question we have. We have just solved here 18th. Now we'll try to solve the 19th. There's a very simple question they have asked to find the value of, what to do? We need to find the value of, that is 19th question I have, cos inverse cos 7 pi upon 6. Okay, cos inverse cos 7 pi upon 6. We have this. What we can do here, we can write as the value, it is 7 pi upon 6. So we can take as cos 2 pi upon pi upon 6. If I take this value 2 pi upon 6, now it will not work like this, because we have to see that the cos x is positive in first quadrant and in second quadrant. Okay, So if I see this 12 pi, now it will be 11 pi by 6. So if I use this 3, now it will not look like this. So let us see how we can solve this question now. So we can write this as 2 pi minus 7 pi by 6 here. Okay, because in first quadrant, in second quadrant, cos is positive. So we have 2 pi minus 7 pi by 6. So we have here, if I try to put it, it will be 5 pi by 6. Okay, so that is a value that we have got here. Now what we can do here, if we find the value. Now for 20th question, now we have what we have the 20th question to find the value of this, that is sine pi upon 3 minus sine inverse minus half. Okay, we need to find the value of this. How will find the value of this? Let us see. Sine, we have pi upon 3 minus sine inverse. We can write as sine minus pi upon 6. Okay, we have this. So what will happen now? We have sine pi by 3 minus, if I try to solve this, we'll have plus pi upon 6. So what we'll have? Sine, if we have 6, so we have 2 pi plus pi. Okay, so we have sine 3 pi upon 6. So we have sine pi by 2, it will be 1. So that's how we able to find the solution. Now let us try to solve one more question. We have tan inverse root 3. We have tan inverse root 3 minus cot inverse minus root 3. So they have given this. So what we can do here, tan inverse root 3 minus cot inverse minus root 3. Now we have this tan inverse, I can write tan pi by 3 minus cot, I can write as the cot inverse cot. We have here the value, that is cot minus pi upon 6 we have. Okay, so we have here pi upon 3 minus. So now what we'll have, we'll try to solve this. If I put cot inverse cot pi minus pi upon 6, okay, but it will be minus here. So it will be pi minus pi by 3. So minus pi, so 5 pi by 6 I have. So if I try to put a value here, 2 pi minus 5 pi by is equal to minus 3 pi upon 6. It will be minus pi upon 2. That is my answer. Let us see. I hope it's clear to everyone. We have tried to apply the properties of inverse trigonometric function in the numericals. So first question arises that we have to learn these properties so that easily we can apply in the numericals. So I hope it's clear to everyone. If you have any doubt, you can ask, comment, share, and please also like my channel. Thank you.